Today we started our journey into nuclear physics. We really started by looking at the fundamental forces and saw that there were four fundamental forces which can explain the interactions in the universe. These were two familiar forces to us, the electrostatic interaction and the gravitational interaction, and two slightly less familiar, the strong force which holds the nucleus together, and the weak force which is used to explain beta decay and controls how up and down quarks behave. From there we've gone on and looked at binding energy, and we've seen that as we bring all the nucleons in the nucleus together, their combined mass in the nucleus is less than their individual masses outside the nucleus, and we've explained this in terms of the binding energy. We've sketched the binding energy per nucleon curve and shown that elements to the left of iron 56 energy can be formed by fusion processes, whereas elements on the right hand side of the curve, fission processes, generate energy. We then went through a calculation to look at the energy from the fission of uranium-235 and explained how nuclear fission works in terms of the excess neutron coming in and the careful balance between strong and electrostatic forces beginning to break down until electrostatic repulsion causes two fragments to be formed. And as well as the two fragments, we often see up to 3 neutrons and kinetic energy. We then went through and looked to calculate similar calculation for the fusion of deuterium and tritium and saw that gram for gram fusion tends to create far more energy than fission. Okay, so using fusion we can have vast amounts of energy. The problem that we have with fusion, of course, though, is bringing together these positively charged nuclei close enough so that the strong force can take over, and this takes large amounts of energy. And the typical places where this is seen is either in a nuclear weapon or in the sun itself, or in certain laser facilities, for example a Joint European Torus jet at Culham, or indeed the National Ignition Facility using lasers in the United States. From here we're going to go on and look further into how we control nuclear reactions, so building nuclear power stations and nuclear weapons, before finally rounding off the course with a brief look at some particle physics.